Hello and welcome to Reimagine Semiconductor Fab Operations with the Digital Twin. Today's webinar is sponsored by Siemens and produced by SmartBrief. My name is Scott Becker with SmartBrief, and I'm excited to be your moderator for this webinar. Now, we've got a lot to cover today. We can't wait to get started, but first, we want to go over a few housekeeping details that'll help you get the most out of the session. So first off, the chat tab on the far right-hand side of your screen, a lot of you have already been saying hi in there. We love to see where you're logging in from. Got people from Munich and Texas and California, PA. It's great to see that. And if your state or country seems underrepresented, you can correct that by giving us a greeting in there. So that chat is for hellos like that, but you don't have to stop there. You can share your thoughts about today's topic, your reactions to things that are said in the presentation, any insights that you have that you think other people might benefit from. Whatever you're excited about, we'd love to see you in there. And a quick reminder, the chat tab is where you go if you need to reach out to the SmartBrief team in the unlikely event that you have any technical issues during the session. Browser refresh will fix a lot of things. Also, there's a light mode option down at the bottom of your screen that limits some of your functionality and puts you on a slight delay, but it can really help like if you're having a local connection problem or something like that. Now, if none of these steps fixes a problem, my colleague Riley and I are standing by to help you out, and we'll be monitoring the chat for any issues that you might have. Now, the absolute best way to dive into the information we're going to be exploring today is by asking questions. So let's take one jump over in the tabs there on the right side to the Q&A tab. Make sure we all know where that's located. So while chat is for all those general thoughts and ideas, the Q&A area is where you should go to ask questions directly of our expert presenters. So that's the queue that we'll be looking at during the Q&A portion. We always do our best to get to as many questions as we can, either verbally during Q&A or by typing in responses, but we do have a lot of info to cover today, and depending on how many questions we get, we may not get to them all during the session. If that's the case for your question, don't worry. We'll make sure to pass along all of your questions to the team from Siemens for follow-up. Now, another stop on our console tour today is the Docs tab. One thing you'll find in there is the PDF of the slide deck from today. So go around in the Docs section and explore. Also, we're going to be doing a couple of polls during the session today. We want to hear from you on those. Those polls will show up also in in that tabs area. Whenever a poll is live, a poll tab will show up there. One more thing to be aware of, we have closed captioning available in 18 languages. If you hover over the lower part of your screen, you'll see that CC option as well as a drop-down menu to pick a language. Now, finally, you may have noticed the prize icon. We are, in fact, giving away an Amazon gift card worth $250 as a prize drawing at the end of our webinar. You must be in attendance for the duration of the live event to qualify for the prize, and you've got to meet the SmartBrief prize terms and conditions, which you can also find in the Docs tab. Okay, with that housekeeping out of the way, I think we're ready to get into our session. So today we're going to explore how the digital twin is redefining what's possible in semiconductor fabrication. You'll hear from innovation experts on the front lines, and you'll walk away with practical insights and real-world examples, showcasing how this transformative approach can cut costs, streamline operations, and drive measurable results. And I'm excited to introduce you all to those experts right now. So let me bring them on stage. And we have Michael Muncy, who's Vice President of Semiconductor and Electronics Industries at Siemens. And we have Ben Green, who's a Digital Solutions Architect at Siemens as well. And Michael, if you can go ahead and just click to accept to come on stage. Well, hi, Ben. How you doing?
I'm here. No, I'm doing very well. Thanks for having us, Scott. It's great to be here.
Good. Thanks for being here. Let me cancel that request to Michael and see if I can bring him back on. Yeah, it looks like Michael's screen might be a little bit frozen, so we'll give him just a second to hopefully pop back on.
Scott, while we're waiting for that, are Michael and I eligible to win the Amazon gift card?
You are not.
Oh, okay. All right.
The Amazon gift card is for attendees only.
Okay, all right.
So, yeah. I'm also not eligible for. I'm also not eligible for
There
the
he
gift
is.
card. Hey, all right. Hey, Michael.
Yeah, just had to do that browser refresh. I'm here now.
Excellent. Well, thanks for joining. Ben and I were just discussing how we're not eligible for the $250 gift card.
But I am.
No, you are also. It's audience only. All right. Well, Michael, maybe just to get us started, maybe you could just share with the audience what the comprehensive digital twin is and how it provides value for the semiconductor industry now and in the future.
Sure. So, in the semiconductor industry, it's interesting. We've been using digital twins for a very long time, but we haven't really called them digital twins. And, I like to say that, if you go back far enough in semiconductor design, we were probably one of the first industries to actually use digital twins. And what digital twins really are a way in the virtual world to not only model the way you do design, but also model the way that you do manufacturing. And by doing everything virtually front, you have the ability to actually find issues and fix issues quicker and much more efficiently without having to do them real time. So I mentioned the semiconductor industry. This is the way we've done design for 60 plus years, right? But it's kind of new now when we start talking about getting into the world of manufacturing, how, the comprehensive digital twin can actually help us in the semiconductor world. And to kind of point out how it can actually help us, it's good to look at the current state of where we are in terms of semiconductor design. We push out new process nodes, roughly every 2 years, but even that's kind of changing if you kind of peel back the onion a little bit. For 50 years we had planar transistors, and when those stopped working, we moved to FETs. And we've had FETs working for about 10 years, but now they're starting to reach the end of their useful life. And we're going to start moving to gate all around technology. And if you look at how long that's going to be around, it's probably going to be around much less than 10 years. And then we're going to have to start looking at stacking transistors, much like we do in DRAMs, but now for general purpose logic. So not only pushing new process nodes, the underlying technology behind those process nodes is starting to accelerate. 50 years for planar transistors, 10 years for FETs, 5 to maybe 7 years for gate all around, and then we'll move into new technologies. So there's a lot of, pressure being put on the entire system. And now we have the actual people producing products that do new product development, and they're pushing out new products roughly every 2 years. In some cases, a lot faster than that. If you look at, NVIDIA right now, pushing out new architectures almost on a 6 month type of scale. So if we're a foundry and we're trying to, keep up with new process nodes, and then we have the pressure of our customers that keep pushing new designs into us, we have to make sure that we could actually be able to produce those designs and produce those designs in newer processes. So the old way of doing this was running test wafers. And we would run test wafers for a couple months and ramp up production and try to increase yield. Um, happens in real time. So therefore, it takes real time to actually start ramping up these new process nodes, and it costs real money. Money in terms of materials, money in terms of depreciation of the equipment that's in these fabs. And, this starts to get very expensive. And we're also switching in these new process nodes from, a month to build a wafer to multiple months, approaching, 5 months now to get a wafer through. So if it took us 6 months to ramp a process node and we were doing 1 month, 1 month per wafer, now if we're at 5 months per wafer and it's going to take us a couple wafer runs, it's going to push us out into years to do this. And that's just not scalable anymore. And so we need to really start to figure out, how can we start doing a lot more of this in the virtual world and leverage what we've done in the past. And this is the production inside of the fab. And we can even extend this further when we look at the entire fab and the entire infrastructure of the fab. And what effect is this having in terms of, chemical usage, water usage, wastewater treatment, HVAC systems, electricity distribution? there is a lot more we could be doing when we look at the entire problem across the entire ecosystem of semiconductor design. So really, what we're trying to do now is take something we've done really well in the past, which is how we design semiconductors and how we do that in the virtual world, and now link that into the world of manufacturing and extend the digital twin. So it's not just design, but it's design and manufacturing. And how can we not only feed forward information, but also feed information coming back? And that's what we're really starting to look at towards, doing now in the future. Because, we have the technology and the capability to start extending this. We've done this in many other industries, right? And now's the time and the perfect time for this industry to start to look at this. So it's really about that starting point I mentioned before, where we could do virtual designs, and what we hand off, when we hand off a GDS2 or ASIS file, right? That's a virtual model of what the design is that we're ultimately going to build, right? But now, how do we start modeling the fab and start modeling manufacturing and start monitoring all the processes in a virtual way, so we could take this information and actually now in the virtual world ramp a process node, ramp a new design on a new process, tweak the process all virtually, so we have a much better starting point moving forward. And that's the feed forward aspect of what we're talking about here. And there's also a feedback aspect, right? Because we improve processes over time by actually measuring what happens in the manufacturing world, right? So can we now accelerate taking information back from manufacturing and improving PDKs, so we put better designs into the process? Can we start looking at alternatives to the way that we've done things, where in the past there'd be a single PDK or a family of PDKs that would be used by all customers to do designs? Can we start now understanding the types of designs that are doing better and come up with custom PDKs per customer, per design per customer, to help them produce better designs that are more manufacturable moving forward? So there's a lot that we could do in terms of the virtual world to start to optimize the entire process. So when we talk about the comprehensive digital twin and what that means for the semiconductor industry, it's extending what we do in design already into manufacturing, allow us to do a lot more in this virtual world and be able to ramp process nodes, optimize processes, capture important information to improve PDKs and libraries and methodologies, and feed that back. And really, this is what we are talking about when we talk about the entire comprehensive digital twin. So I think with that, Scott, I think we have a poll to ask the customers, where they actually see these challenges right now.
Yeah, absolutely. So I've opened up that poll. It's over on the right side of your screen. So that's, in between your chat and docs tab. So you can vote in there. And the question is, in your opinion, where could the manufacturing digital twin provide the most value in the fab? And the answers there are virtual models of semi-manufacturing equipment, virtual models of production processes, virtual process modeling, virtual 3D IC design, and virtual meteorology. So those are the options there. We've got some fair amount of votes coming in, and it's a pretty good spread. So we'll just give everybody just a minute there to respond to that. Okay, I think we've got a pretty good sample. Let me go ahead and let me give everybody a 5-second countdown to get your last votes in. 5, 4, 3, 2, 1, and the poll is closed. Let me go ahead and share that on stage here. So, gentlemen, it looks like models of production processes was the far and away winner at almost 50% of the votes. Yeah. And next up was the semi-manufacturing equipment. Does that line up with what you guys are seeing? What do you think of those results?
Yeah, and that's not surprising. And it's exactly what we see, and when we talk to customers, what we're hearing. The questions of the polls, they're all interrelated, right? But it really starts at the modeling of the production processes. And this is where we're actually being asked for the most help. And the fact that the virtual models of manufacturing equipment is closely tied to that, because they're interrelated, right? to do the production processes, you need to also have the equipment. And, ideally, you also have the virtual models and equipment feeding into the production process. And, where we're engaged right now with customers are actually in those top two right now, and modeling the process and working with the equipment manufacturers to be able to go ahead and drive that forward and linking with the production process. And do you see that as well, Ben?
I do, and I was happy to see this was the outcome, because if it was something else, I was gonna have to change some slides here in a minute. But no, I do, and I think kind of really a key takeaway for me for this is not really surprising at all, because it is probably the number one thing I do get asked about from our semiconductor customers as well. Maybe a little different shade on it or take on it is that, Michael, I know you're 100% focused on the semiconductor industry. For myself, about 50 to 60% of my customers I work with are semiconductor, and the rest are spread across various industries. But I would say that this is consistent across those industries as well, which to me I really is telling, is that not just semiconductor, but oil and gas, machine builders are also looking at these same things. Is how do we not just go from a design point to how do we do the full production process?
All right. Excellent. So let me stop sharing that. Come back into the slides. Yeah. So now that Michael's provided that overview, the comprehensive digital twin, its relevance to the semiconductor industry, the next thing was to take a look at some use cases and ways that steps can be taken now to take full advantage of the digital twin in manufacturing. So, Ben, would you care to the first case study?
Sure. In fact, I'll tell you, this is you kind of get a twofer with this one and with this first use case. And really, this is probably the number one question I get is, okay, Ben, we want to do digitalization. How do we get started? Like where do you go? And probably the most basic answer, the most kind of low hanging fruit that a lot of customers tend to gravitate towards is really using a digital twin in what I like to call design mode. And it's like, hey, we're going to do a new design. It could be a design of a product. It could be design of a plant layout, of a manufacturing floor. It could be a design of a new piece of OEM equipment. It doesn't really matter. But I think a lot of people and a lot of customers tend to gravitate towards this idea of using a digital twin and using it for design mode. And we all get that beautiful 3D model kind of in our head and how we might use that. And I think it's a great place where just a lot of people just tend to start with it. So, using it to look at plant layouts, for example, in a brownfield scenario where maybe I'm thinking about how could I rearrange some equipment to make product flow through my fab or my facility better, faster, or more efficiently. We have customers doing that all the time. The other big one that we see a lot is we're thinking about a new design. We've got our R&D team is thinking about, hey, what if we do this differently in our new greenfield that we're building? Is using the design mode to catch mistakes ahead of time. The old example is hey, I've got a product coming off the end. The conveyor belt can't turn 90 degrees because there's a wall in the way. Like, how do we catch that? If you catch that after the cement's poured, weeks of rework, jackhammers, concrete being torn up, all that kind of good stuff can happen. But if we can catch those types of mistakes virtually ahead of time, you can save a ton of not just money in mistakes and costly mistakes, but it's also time, because you're not extending out, you're not having delays that you weren't prepared to or accounted for. We also look at things like physical design, so making sure we have the pumps sized correctly, motor sized correctly, the electrical system sized correctly. All of those types of things we kind of do, like I said, kind of this design mode to validate and make sure that the design works really well. But if we kind of take a step forward here, is I like to tell customers is there's the design mode, and there's this idea of using the digital twin for design, but how do we wring even more value out of that? I mean, if we're going through this effort of creating this comprehensive digital twin, is really then how do we maximize the benefit out of it? And I think one of the two areas that I see, in fact, I would call this the second most important, or my second favorite at least, use case here is really about taking that design and then what else can we do with it? And one of those things is virtual commissioning, for example. So not just designing a piece of machinery or designing the fab or designing the FMCS or whatever it happens to be in the semiconductor world, but then how do we actually go and commission it virtually ahead of time so that we know the code and the controllers, the PLCs is running correctly, we can pre-tune and pre-validate PID loops and drive settings and valve positioners and all that kind of good thing, and simulate what happens. What happens if we have a failure? What happens if we need to replace something and run while the facility is up and running? So being able to take that same model, that same information that I used to then drive all those benefits in the design of a new plant or new fab, I can now take that same model and then allow my automation guys and team to then start working that model as well. And they can now start doing things in parallel with design while the plant's being built, while the fab is being built. It takes a significant amount of time to build a new fab. Instead of waiting till the end to then be able to do the commissioning and the testing and all that stuff, let's do that virtually. Let's pull that forward. Let's shift that left into the design mode, and that builds in this idea of this time savings, which is really the kind of the one resource where I think we all agree that we can't get back. And so we can pull that in. And then the other piece of it, where a lot of customers, like I see this light bulb go off with a lot of customers, is the idea of virtual training. Is now taking that 3D model and bringing in a workforce that I have to train. And in the past, you have to hire someone, you have to bring people over from maybe a previous fab to start up a new one, an experienced team that knows what they're doing, bring in veterans, and then you're going to hire new workers, and you have to train them. And so are they shadowing people around? Or are they just watching videos on the web? How are you doing that training? And I like this idea of putting workers into virtual environments, is letting them actually touch and see what that's going to look like in the real world while the fab is being built. And so we can actually put them into all sorts of different scenarios, and including like dangerous scenarios. And I always tell customers, and this may be, I'm an airplane guy, and so one thing that may be a little disturbing for some people to learn is think about airlines, right? And you got a brand new captain of a 777 or co-pilot in a 777. A big airplane. You got the first time that co-pilot touches the controls in an actual real 777 is he's got 250 people sitting behind him, because they do all the training virtually in simulators. And I think from an industry perspective is being able to take workers and be able to also do that same thing. Maybe doesn't need to be a full motion simulator like an airplane, but we can also do that with a digital twin, and actually taking those exact same design models, commission them with all the operations guys, and then also turn around and train our workers using those exact same models. And again, be able to compress that time to production.
Okay, well, the next use case we're going to be looking at is predictive maintenance, which is important in any industry, but perhaps even more so in semiconductor because of the very high cost of downtime. So, Ben, can you tell us how AI-powered PDM ties into the comprehensive digital twin?
Sure. So this is also a very interesting use case too, and this is kind of one of those, I would call it one of those underrated use cases for a digital twin. And in fact, a lot of people in the audience, they might be thinking, hey, how does predictive maintenance, how does that even tie into a digital twin? What do they have to do with each other? And certainly in a kind of a brownfield situation where I've got an existing fab, and we've done this with multiple customers now, is we have a really robust maintenance solution that's AI based. It can ingest all kinds of data, not just like vibration and power consumption and things like that, but also take into account, what's being run, what product is being manufactured, what's all the status around it, and be able to, make decisions. But one of the areas for predictive maintenance that I think is really interesting that we're doing is being able to take a digital twin and actually plug the digital twin into the predictive maintenance algorithm. And you say, okay, well, why would you want to do that? Well, the key thing here is now we can validate how our predictive maintenance algorithms are going to work in the real world without having to deploy them and test and see and tinker with them on running equipment. We actually can take and apply the predictive maintenance algorithms and the predictive maintenance applications, apply them to a digital twin, and then take the digital twin and inject problems into it. So we can actually make a bearing vibrate, or make a pump cavitate, or make whatever we want to do. We can change all that in different scenarios, and we can see how our predictive maintenance algorithms behave, and not just how they behave, but also taking this idea of synthetic data and having the digital twin throw off the synthetic data and training those AI models with the digital twin. So when we're building a new fab and people and things are ramping up, we can bake in predictive maintenance, and we can validate it ahead of time and know that it's going to work on day one when we're ready to start up the plant, as opposed to having to wait in that kind of that call it more traditional predictive maintenance, where you have to wait for a problem to occur, identify it, and then teach the AI model on actual problems that have occurred. This way, we can create the problems synthetically or virtually, have it train the AI model so that on day one, the predictive maintenance is I won't say 100%, probably won't be 100% dialed in, but it'll be so much further along than trying to put that in after the. So it really shorten that time to production, and then really shorten the time to be able to bring in these predictive maintenance. So now, from a workforce perspective, right, your maintenance team could be smaller. It could be certainly more efficient, and we really are again using that digital twin for that next iteration of use cases. So kind of an odd, I would say it's an oddball use case, but it's one of those use cases that I think is really underrated, and we're seeing on so many customers really gravitate towards this idea. And maybe just for like a little bonus is this idea of synthetic data is if you're in the audience, for the audience that are here, if you're doing AI, this idea of synthetic data, this is probably a webinar in and of itself, but it really is, I think, is going to be one of these kind of game changers, is taking not just the AI, the real world process data that everybody has at this point, but now how do I actually generate the synthetic data to train those AI models? And so I can have these other use cases come up for it without having to actually wait for a problem or this data to show up in the real world.
Yeah, synthetic data is definitely something you hear about. Like, we do a lot of webinars across, AI is everywhere, and you're seeing synthetic data as a use case all over the place.
Yeah.
Not with the digital twin there.
Yeah. AI, this is a great place for, customers will come to us all the time and say, hey, we want AI. What does that mean? And this is a great place right here is a great place to use it. If you're in the audience and you're thinking about, hey, where can we use AI? Where's an easy place? This could be a fairly easy on-ramp here, is in the predictive maintenance kind of realm.
Interesting. All right. And then the last use case is about sustainability and data, which, as you mentioned in the previous use case, is critical in the support of any short-term as well as a sustainable long-term digital twin strategy. So, Ben, can you tell us a little bit more about this one?
Sure. So this is actually my favorite, one of my favorite use cases. If you mentioned, I mentioned before the virtual training and the virtual commission was always my second favorite. This one really is my favorite, and this really goes back to something Michael said really early on. Is this aspect of a feedback aspect to a digital twin? And if you leave with nothing else, I think this is really one of the places where so many customers that come to us and want to do a digitalization project or a digital twin project, this is where they fall down. Is they're in design mode, they do the design up front, and then that digital twin gets put on a shelf and it goes into the library somewhere, never to be seen. And we did design the fab's running, and we're good. But this idea of using a digital twin in a sustainable way, and when I say sustainable, just make sure that we're talking about a bigger context than just saving energy or being green or carbon footprint reduction, is really sustainable in how the plant sustains itself from an energy efficiency standpoint, of course, but also just from a maintenance standpoint and a longevity standpoint, is this idea of feeding the actual production data and having that feedback loop back into the digital twin to make that digital twin better and better and better over time. And this is really, I think, that's really the critical thing for customers to really want to be successful at a digitalization project or a digital twin project. You've got to refine it, and this becomes this living digital twin, or this comprehensive digital twin, is having that feedback loop. And it unlocks so many things for customers. One is you can see in real time, hey, this is what we modeled, this is what's actually happening. Why doesn't it match up? So the digital twin is always getting better, can be improved upon. It allows you to simulate different things in the plant. So maybe I've got a machine, or something is down for maintenance. A pump is down for maintenance. What is that going to do for my production? Or better yet, I know that I'm going to need to do maintenance next week on these 2 or 3 assets. It's planned down, maybe plan for those assets to be down. what will that do to my production? So now I can simulate what effect that'll have, and I can plan ahead of time. I can plan, make sure I have the right manpower in place, I've got the right backups in place. What is that going to do? What's that going to do for me? Also energy consumption. So where are the energy hogs? So back to that kind of the green carbon footprint reduction is what assets in my plant, whatever it happens to be, how are those, what kind of resources are those consuming? And then now, as we think about how we do retrofits or we do process improvements, we can actually look and see, hey, this is what we think. This is where we know, not where we think, where we know we have a problem. We know this is this compressor, for example, is an energy hog. What happens if we replace it with a newer compressor or a larger compressor? We can simulate that in the digital world with the digital twin, see what happens and how that would affect production, how that affects my plant, how that affects my energy consumption, my footprint. I can know all that ahead of time because I have the real data and I can do it. And the other piece of it is kind of going back to the synthetic data piece and the AI piece is once I have a closed loop feedback, now I can apply AI strategies to running operating equipment because I have the data. The AI model can chew on it. We can train up the AI model. We can play with it. We can simulate different scenarios for it and how it's going to react, and we can actually all that back into it as well. So another kind of real kind of underrated use case there. And I think the last piece of it is really about is thinking about you're going to build a new fab today, right? And you're going to invest billions of dollars to build a new fab. Then you're going to want to build another one and another one and another one, right? I mean, there's no shortage of the need for semiconductors. And as Michael mentioned in the first slide, is the process nodes are ramping up. We need more and more and more. Well, as you have this feedback loop and you're constantly improving that digital model, you don't have to start that digital model again from scratch. It's now these models go into this library that are continuously improved. And so as you have your design guys going back into that design mode, they now have a better model to work with, real world data to work with. So as you're making design decisions for Fab 2, 3, 4, however many, they can make better design decisions because those models are kept up to date and they've been refined over the years or over the months of operation. And so you make better design choices for future plans. So really, this is the critical piece is not just a digital twin for design purposes, but how do you feed it back and how do you integrate that into your company's processes?
And just to add one thing to that also, because it also ties together nicely what Ben said, both in this one as well as talking about the AI piece. We're talking to more and more customers that are actually looking to build the greenest products moving forward, right? And that, ties into supply chain. And when you're going after discrete components, yeah, you could get some idea of measure how green those components were produced. But the big hole has always been, how about the semiconductors the custom chips that I'm putting into my products? How do I know how green they are and how can fabs actually report out how green they are, right? And this is where it comes into sustainability and be able to measure a lot of this going along. And so it's not just reporting out the data. What are the fabs going to do to be able to optimize the actual production processes to make them more sustainable and be able to report out? And this goes right back to the digital twin, because we have all the information. You can actually start seeing what you could actually do during a production run to actually increase the sustainability of a given product running through a given line and actually be able to mine that data also through AI and be able to also optimize the process moving forward. And I think it's only a matter of time before people actually are not only competing on things like cost and yield and ramp to volume, but also on sustainability metrics. And the only way to be able to measure those early on is through a comprehensive digital twin where you have access to all this moving forward.
Interesting. Yeah. Well, let's do another poll. Let's bring everybody in for that. So we've got another poll open there on the right side, and this one is, if you're exploring the digital twin, what are your digital twin top priorities for the next 12 months? Are you guys thinking about reducing operational costs? Is it improving yield and utilization? Is it about enhancing predictive maintenance? Is it about achieving sustainability goals, or is it not relevant? Digital twin for you guys. So just give everybody, a little bit to respond to that. We've got some responses coming in. We've got a couple of leaders. I don't want to influence the results by telling you what other people are voting on, but it's coming across here. So let's give that about another 10 seconds just for everybody to respond. We'll give a countdown here from 5, 4, 3, 2, 1. All right, let's close this poll out. And let me share the results. So, gentlemen, we got a lot of people, and the leader was improving yield and utilization, and I think followed by operational cost. Does that line up with what you're hearing, customers?
Yeah, yes, it is. And in this, the starting point is right, going right to the bottom line, right? We want to improve yield and utilization, which goes to actually the cost of, and then the operational costs go to the bottom line as well. So again, not too many surprises there. But I'm also glad to see in terms of the predictive maintenance also behind there as well, because again, those also start tying into the overall operational costs. So again, yeah, not too many surprises there.
Yeah, I would also agree. I think this lines up pretty well with what we see across the industry and across the other industries as well. Certainly, I think always in semiconductor, yield and utilization is always the top, one, of course. But I think a lot of all the other ones here as well, especially the predictive maintenance and the operating costs, they feed into that as well, of course. And so I think it's a pretty good smattering of results here.
Okay. All right. Excellent. All right. So, now that we've gained that understanding, of the comprehensive digital twin and heard some of the relevant use cases, let's talk a little bit about how to implement the digital twin. I'm assuming it's not a one and done exercise.
No, it's really not. I mean, I think Scott, I think the big thing here is that if it's a one and done exercise, I think it'll be disappointing because it takes some effort, right? It's to do a digital twin to really do and especially the comprehensive with the physics and the the really high fidelity digital twin. It takes some effort, and if it's a one and done project and you don't have that kind of a goal in mind of how you want to use it, that makes it tough. Where we're really successful with customers, and where I see customers be really successful, is they have a lighthouse goal that they're out there chasing down. We have a vision that they want to get to, whether it's a lights out manufacturing, whether it's complete AI process control, whatever it is, and they want to get to a point. When they have that vision, then it makes it much easier is then to define, okay, what problems are we solving today? How could we potentially solve it with a digital solution, potentially a digital twin? And how does that feed back into the solution that we do today? How does that feed and grow into that goal in the future? And that's really the key point. I think that a lot of customers, when we're really successful, is we can draw that line between today and tomorrow.
And I think, one of the key things here is that this is an entire ecosystem that has to move forward in this direction, right? There's certain things that people do as the first steps, but we're also seeing our customers reach out to us and asking for our help in bringing the ecosystem together. We have fabs asking us to reach out to semiconductor equipment manufacturers to help the equipment manufacturers provide data that the fabs could use to enhance their digital twins right now. We actually are now starting to see equipment manufacturers reach out to us because they know that if they're able to help their customers do virtual process ramps, their ability to provide a model into a comprehensive digital twin will help them be more competitive because they're helping their customers be able to do things virtually, right? So there's, every journey starts with a single step, and there's certain places that you want to start moving forward in adopting these digital twins. The good news is that, we partner with our customers and help them map out what that journey needs to be, and also how to get access to the entire ecosystem where, ultimately we're going to have both the semiconductor designers, the manufacturers and the fabs, and then the equipment all coming together to support this to be able to build this out.
Yeah, and Michael, maybe you can tell us a little bit about how Siemens specifically helps out with that.
Absolutely. So, the first thing here is that we have been working with customers in multiple industries for ages, right? On, helping them build out their digital twins. And we're able to leverage other industry when we are able to help specifically in the semiconductor industry. The automotive industry and the aerospace industry have been doing digital twins in manufacturing for many years. And as I mentioned before, the semiconductor industry has been doing digital twins of design for many years. And so we're kind of uniquely positioned here in that we have a strong semiconductor background as well as strong other industry knowledge that we could all bring together and actually, start being able to deliver this across the entire semiconductor value chain from new product introduction and system level design into semiconductor design and functional verification into implementation and validation and bringing in software when we talk about software defined products and how all that feeds forward down to manufacturing across the entire ecosystem. So it's a strong point for us. And not only that, it's the fact that we're working with all customers across the entire ecosystem, and we're able to help build the alliances and link parts of the supply chain and the value chain all together to start to be able to make this actually a realization for the semiconductor industry. And then, as Ben mentioned earlier, also, our investment in AI really helps here as well. The semiconductor industry produces vast amounts of data, probably more data than any other industry. And I used to call it, this data is unleveraged assets, right? There's information coming out of the EDA tools that could help actually drive forward into manufacturing. There's data coming out from the manufacturing process that could be better utilized to help improve. So, the fact that we're building the AI solutions across all of this data as well is really, helping us position ourselves to be a leader in the space, and our customers are starting to realize that as well. So just to summarize a little bit here, right? This is all about, completing an ecosystem. We do a very good job as an industry, as I mentioned before, upfront in that design stage, and we hand off a virtual model for manufacturing. So now it's just completing that whole flow and being able to start to model processes, start to model actual manufacturing, start to model the entire fab to really, build this out. And then, this is going to happen because of the entire ecosystem coming together and the fact that we're working with the entire ecosystem across the entire value chain here to be able to drive towards this digital twin for the entire semiconductor industry. We back this up with the use cases that I just talked about. And these are use cases not only from the semiconductor industries, but from other industries that we could adapt and bring forward to actually give us a strong foundation and starting point forward. And the fact that we have, a very strong semiconductor background, both from an EDA point of view, from a product introduction and manufacturing point of view. We build our own semiconductors for our own products. And so we're constantly testing these ideas and these thoughts, within our own company, driving this forward. So it's really taking all of this proven technology across many, many industries and pulling it all together to drive forward with the digital twin. So, all this material is going to be made available, and please be on the lookout for more information coming from us and emails from us to further point you in the direction of getting more information. But there's also a QR code here with an article about the digital twin, and it also links to other content that I would encourage everybody to take a look at, and it kind of fills in some of the details that both Ben and myself talked about during the whole session here today. So
Excellent.
with that, Scott, I think we're ready to take a look at some.
Yeah, we've got a bunch coming in. So first one here, what are the typical ROI timelines companies can expect after implementing digital twin technology in their fabs?
I know we've got a couple use cases, Michael. I'm sure you've got probably some
Yep.
some examples as well. I mean, maybe one that's like pretty recent here. Actually, in the last probably couple of months, we did really two. One is we've done a solution with a major, I call it a semiconductor manufacturer for process optimization around chillers. So chillers, as we all know, chill water is huge in the semiconductor industry. It's a huge energy hog as well. And so we actually worked with them and I don't have the figures here, but it was something like, I don't know, $5 million a year for like 2 chillers for just the energy usage alone. And we were able to save them something like 8 or 9% just by using digital twin and then optimizing the operation of a digital twin with AI. So we basically have, bring in settings for weather and operation of the plant and how we came up with a new algorithm. And there's plenty of people out there that have chiller optimization strategies. That's kind of a low hanging fruit piece. But when you do it with a digital twin, the value they really got out of it. And by the way, the ROI was, I don't know, 2 or 3 months is the payback on it. But we solved that one in such a way that they can take that same methodology and apply it not just to chillers, but to air compressors and vacuum pumps and all sorts of different equipment that they had running down the list. And so we come up with kind of this idea of a repeatable solution for them that can be applied multiple places. Another big one from the OEM side of the semiconductor world is this OEM equipment is expensive. And we had a customer just recently, we built a digital twin for them of their machine. And so this machine is, millions of dollars. And so for the OEM just to have one to test and play with and have their controls guys test new control code, to have one just sitting on the floor is a ton of working capital that gets tied up in space and all kinds of stuff in their plant. And we actually able to create a digital twin for them. So now they're PLC programmers, they're guys that are working on the automation on the machine. They now have a virtual test bed and they can test out new code, new algorithms, new whatever AI pieces. They can test all that in a virtual environment without having to have an actual physical asset just sitting on their plant floor or in their shop floor just for testing purposes. So that was a pretty neat one that we just did as well. And again, payback was, $5 million of capital equipment just sitting there, and now we did it for, I don't know, it was a $150,000 kind of project. So kind of see that.
Just to add one more thing, also, we worked with a semiconductor customer right now with some of our virtual metrology, which was actually part of one of the poll questions earlier. And immediately we saved them roughly 6 weeks in terms of production ramp time just with that technology alone, right? So I think to summarize it, the ramp to ROI happens fairly quickly because of the vast amount of data modeling that we've already done. In any starting point, even the smallest step starting point tends to lead to some amount of return fairly quickly on the investment when we start to look at this.
All right. Excellent. We have a question here from Richard, who's actually wondering something that I was wondering as the discussion went through. And Richard's saying, referring to a slide from before, that it implies that virtual training might be conducted using VR goggles. But how do users interact with the digital twin? Is it on big screens? Is it on VR goggles? Is it in apps? What are part of the solutions?
I would say all the above are options. It could be VR if it's some sort of process that involves maybe a maintenance repair, or you're changing in and out equipment. Maybe it's I don't know, some sort of like UV light source or something, that piece of equipment that has to be changed out periodically, right? Is you could do that virtually with goggles on, and we got to need to loosen up these 5 bolts and make sure they're torqued back to the right specs, and you know exactly what wrench and what equipment to use and how things come in and out. So it could be a VR experience. It could be something as simple as an exact duplicate of a SCADA screen running against a digital model so you have someone just that knows the layout of the screens. They know how to navigate. They know how to what buttons to press, and not that it's just a dummy SCADA screen. There's the physical model running behind it. So the actual values and the changes and the timing and the errors and the alarms, all of that is very, very realistic for them. So then you can also you get that real world feedback, as opposed to just being like, hey, I push the button, it turns green, great. Okay, no, push the button, it takes 30 seconds for that process to complete. That all is kind of built in there. And then also being able to simulate failures. So being able to simulate things and be able to how an operator should respond to different scenarios that might happen to avoid, unplanned downtime or worst case, a fab shutdown, is being able to work through those scenarios ahead of time. So it could definitely be an all the above type approach.
Okay. Excellent. Next question comes from David. It says, automotive and aerospace industries have been using the DT tools for years in their ecosystems very successfully. What's the biggest barrier to entry for semiconductor industry to deploy and utilize similar proven solutions for semiconductor manufacturing?
I'd say the biggest barrier right now is the fact that so much of the IP has been, closely guarded because of the fact that, if you're not careful, you can leak out important information that then will allow competitors to be able to, copy designs, copy processes. So that by far that's been the biggest barrier, and that's why I talk about this being an ecosystem. It's a matter of the designers when they share their designs via GDS2 and Oasis, maybe also sharing a little more extra information to help build out the twin. It's about foundries, sharing a little bit more information to build out the twin, and so about the equipment manufacturers, sharing more information about their actual equipment to build out the digital twin. So, once we overcome that, that's what's going to lead us to move towards this view of this and we have in the comprehensive digital twin. Now, I'm saying that as that's the problem in the past, right? We're already seeing the need based on, the complexity of the problem of people starting to open up a little bit more, right? The foundries realize that the time to ramp a process is not tenable anymore because of the time it takes to run test wafers and the amount of money that goes into that. The semiconductor equipment suppliers realize that they need to compete more just on what their equipment could do, especially as equipment providers start, competing with each other on similar types of equipment. And so we're starting to see, people starting to open up a little bit and start to share a little bit more data. And that's what's going to lead to actually being able to build out the entire comprehensive digital twin by bringing the entire ecosystem together.
Okay.
I might just add to that just for Harry, because I think I saw the question as well. Is as this sharing and again, I think the data privacy piece and not wanting to share designs, especially OE, wanting to do digital twins into the fab or vice versa, is there's also this concept of you can take a digital twin and you can, I don't know, for lack of a better word, like dumb it down for the use. So maybe you use the parts of the digital twin that you need for what you're trying to solve. So, maybe the fab operator, right? You don't need the intricate details inside the machine, right? You just need to know the basic operating parameters of the machine and inputs and outputs and things like that. So as you're sharing models across different organizations, is you may not need to share you don't need to share the full fidelity model. There's parts and pieces that you can keep internal to you and just share like a wrapper or the shell of the machine to the end user potentially. So that's another way that we see this being used between OEMs and end users specifically.
Okay. All right. Well, we probably got time for one more question and just kind of a quick answer on it. But this one is from Luke, who's wondering, what Siemens products are you seeing applied to digital twin initiatives at customers?
For the example I referenced is it's interesting. For that one, we actually didn't need we did like a 1D design. So we actually used the software tool specifically was called AimSim, where we do like a 1D design where it's just the physics of the machine they need to simulate. They don't really need the 3D model, doesn't really buy them anything. They just need to know the physics and the chemical loops and stuff going on inside the machine. So that was the tool we used there. But certainly we could, if they needed a 3D model, we would bring in those tools as well. Michael, I don't know if you have a thought on it as well, but
yeah. So again, it's multiple tools that all come together on the Siemens EDA side of things. It's Calibre and parts of, especially Calibre Semi, as well as parts of a Fab Insights that come into play. And now there's more of the Tesson technology that's coming into play as well to go along with the SDS products. Some of our Altair products as well that we recently acquired will be brought into this. Things like Siemens Teamcenter, managing all of the data across all of the entire process, so it's really multiple sets of products that all come together to actually, create the digital twin that we talk about.
All right. Excellent. Well, unfortunately, we are out of time. I just put your slide up here with your emails and contact info. And, we did have more questions than we could get to. We'll get all these questions over to you guys for follow-up. But I just really want to thank you, and Ben. It's been a really informative discussion. It's been fun and really interesting. Thanks for being here.
Great. Thanks a lot, Scott. And thanks everybody for joining.
Yeah, thanks for having it. Thanks for everybody joining. I think I saw Tokyo and some other far off places, so that's awesome.
Yep. All right. Well, I'm gonna let Ben and Michael go here. And we just before we get to the prize drawing, we have one quick favor to ask of you all today. So Riley's opening up a short survey that we'd really appreciate if you could all fill out. This is just for those of us on the Smart Brief team. We just want to know how we're doing, what y'all like and don't like about our sessions. We just want to make sure we're meeting your needs, and the results of this survey will affect how we deliver these events for you in the future. So we'll just give you a minute to fill that out. While you're filling that out, I'll just a few things. Once again, if you want to grab that slide deck that you saw today, that's available in the docs section. The PDF is over there. Also, I will throw back up this slide with a QR code in case we moved it too fast for you and your phone, so you can grab that. Okay, and we do have that one more piece of business. That is the prize giveaway that Ben and Michael and I are not eligible for, that we were talking about early on. So today's winner of a $250 Amazon gift card is Zach Uris from Colorado. So congratulations to Zach. As always, we'll be in touch about claiming your prize after the event. Well, with that, on behalf of the Smart Brief team, I want to thank Siemens for making this event possible. And a giant thank you to Michael and Ben again for just a super interesting chat. Big thank you to everybody in the audience for joining us today, and especially those of you who asked your questions and engaged in the chat. Great having you all here for this Smart Brief event, and we look forward to seeing you again next time. Have a great rest of your day.